This is a tutorial on solving polynomial equations. Now, just like solving quadratic equations, solving polynomial equations begins with factoring. And there are many ways to factor a polynomial equation, and the easiest one is finding a common factor. A common factor is just a number that we can take out of both terms or all of the terms of our expression. So here we have 32x cubed minus 2x squared. The easy one to see is we can take out a 2 because 32 is divisible by 2 and so is 2. So if I took out a 2, we'd be left with 16x cubed minus 1 times x squared. If I redistributed this 2 back in, we would end up with our original equation. So that's why we can take out our 2. But the 2 is not the only thing that we can take out. This x squared, since our first term is an x cubed and greater than x squared, this x squared is also a common factor. So we can factor out this x squared. So if we do that, we get 2x squared on the outside, and then we'll have 16 times x, because if I take an x squared and multiply it by x to the first, I'm going to get an x to the third. And then we have a minus 1, because if I take out an x squared from an x squared, we'd end up with an x to the 0. So if I multiplied an x squared times x to the 0, again we would add our coefficients, so we'd end up back to our 2. So to simplify this, this would be 2x squared times 16x minus 1. And this is our factored polynomial. Let's try this again. Here we have a to the 5th minus 8a to the 4th minus 16a cubed. Well, there's no constant we can factor out because this is a 1 and then 8 and 16. None of those are readily divisible by any number. But we can factor out this a cubed. So if I factor out an a cubed, I'm left with, well, a to the 5th minus a to the 3rd, or 5 minus 3, we'd be left with a squared. And we have a minus 8. And then we have an a to the 4th, but we're taking out 3 a's, so we're left with just 1. And then we have a 16 left over. And then this would be a to the 0, because we took 3 of them out, so we're left with 0. So our factored equation then is a cubed times a squared minus 8a minus 16. And this can't be factored any further. So this is our factored equation. Now another way that we can factor polynomial equations is factoring 2 cubes. Factoring 2 cubes is a lot like factoring perfect square trinomials or difference of 2 squares trinomials. So the first one we're going to look at is the sum of cubes. If we have some number cubed plus some other number cubed, then it always breaks down into this form. So x cubed plus y cubed will break down to x plus y times x squared minus xy plus y squared. And the way to do this, here we have an example. We have 8y cubed plus 125. You have to realize that this is a number cubed and this is a number cubed. 8y cubed is the same as saying 2y to the 3rd power. And then 125 is just 5 cubed. So now that we can see that our terms are cubed, we would just substitute 2y in for x in this identity, and then 5 for y. So this would factor out to be 2y plus 5, all of that times 2y squared minus 2y times 5 plus 5 squared. Now if we simplify this, this will break down to 2y plus 5 times 4y squared minus 10y plus 25. Now this won't factor any further, so this is our factored equation. Now let's look what happens when we have the difference of cubes. Again, we have some number cubed, but it's subtracted by a different number cubed. Well, if we ever have that, it'll break down into this identity where x minus y times x squared plus xy plus y squared. But again, the key is recognizing our cubed terms. Here we have 27a cubed. You have to realize that 27a cubed is the same as 3a to the third power. And then 64 is just 4 to the third power. Well, once we recognize that, we can plug in 3a for x and 4 for y. So this will factor down to 3a minus 4 all times 3a squared plus 3a times 4 plus a 4 squared. Now this will simplify out to a 3a minus 4, and then times a 3a squared is a 9a squared, plus 12a, because 4 times 3 is 12, and then we add a 16, and here is our factored equation. Now another way to factor polynomial equations is factoring polynomials that are in quadratic form. Now, neither of these examples are quadratic equations, but we can manipulate them to look like a quadratic equation. So let's look at our first one. We have 10,000 x to the fourth minus 625. If I take a square root of 10,000, I get 100. And if I take the square root of x to the fourth, I get x squared. So if I take 100x squared and I square it, I would end up with 10,000 x to the fourth. So even though this isn't a quadratic, we can make it look like a quadratic by just moving this 2 exponent out.
Same thing with the 625. 625 is just
25 squared. So now you can see that we have two terms that are squared. We can use our difference of two squares identity for our quadratic equations to solve this one. The difference of two squares is that if you ever have an a squared minus a b squared, this is equal to a minus b times a plus b. And then in this case, our a would just be 100x squared, and our b would be 25. So to factor this equation, we would just use this identity, and we'd end up with 100x squared minus 25 times 100x squared plus 25. So even though this isn't a quadratic equation, we can still use our quadratic identities to factor this polynomial. Now 100x squared plus 25 can't be factored anymore, but 100x squared minus 25 can be, and actually we use the exact same identity. These are squares again, so this would break down to 10x minus 5 times 10x plus 5. So then our final factor equation would be 10x minus 5 times 10x plus 5 times 100x squared plus 25. Let's look at our next example. We have a to the sixth minus 8a cubed plus 16. Well, if you can recognize that this a to the sixth is the same as a cubed and then squared again, then we have 8a, or a cubed and then squared again, minus 8a cubed, and then plus 16 is actually 4 squared. Now this isn't immediately recognizable because of this negative sign, but if I said this was a negative 4 squared, because negative 4 squared is still 16, this becomes the identity of a perfect square trinomial. if we had x plus y squared, that identity breaks down into x squared plus 2xy plus y squared. Well, here we have a cubed squared, so if we said a cubed was x, we would have an x squared. And then if a cubed was x, and we multiplied it by 2, we would have a 4a cubed, but then we need to multiply it by y, and we said y is negative 4, so this term would fit this identity, and then negative 4 squared would be our y squared. So we can use this identity to factor this equation, so this would end up turning into a cubed plus a negative 4 squared. Or to simplify, this is a cubed minus 4 squared. Now the last way we're going to talk about in factoring polynomials is factoring by grouping. And to do that, we basically group two of these terms together and try to take out a common factor so we're left with the same factor. That'll make more sense when we do it. If I group these two terms together, I would have an x cubed plus 2x squared. And I can find a common factor in these two of x squared. So if I factor out an x squared from those first two terms only, I would be left with x squared times x plus 2. Now let's look at our second two terms. We have a minus 9x minus 18. These two are grouped together, and I need to find a common factor to take out of these. Well, if I take out a negative 9, I'll be left with negative 9 times x plus 2. So what we have here is x squared times x plus 2 minus 9 times x plus 2. Now because these are both x plus 2, which is what we were trying to do, we can factor out an x plus 2. So we factor out an x plus 2, we just take it to the outside, x plus 2, and what's left on the inside is an x squared minus 9. So we've now used factored by grouping to factor this equation into this. Now this isn't quite done yet because we can still factor our x squared minus 9. This is a difference of squares. So this will break down into an x minus 3 and an x plus 3. So our final factoring then is x plus 2 times x minus 3 times x plus 3. Let's look at our next example. We have 3b to the 6th minus 6b to the 4th minus 12b squared plus 24. Well, I'm going to group these together. So our first two terms, we have a 3b to the 6th minus 6b to the 4th. Well, I can factor out a b to the 4th, and I can also factor out a 3 from these. So what I would have on the outside then is 3b to the 4th times b squared minus 2. So let's look at our second two terms that we've grouped together, the negative 12b squared plus 24. The only thing I can factor out here is a 12, but I'm going to factor out a negative 12. Well, here we have 3b to the 4th times b squared minus 2, and then minus a 12 times b squared minus 2. So we have the same term here, and we'll factor it out. So we end up with a b squared minus 2 on the outside, and then what's left is a 3b to the 4th minus 12. So here is our factor of 3b to the 6th minus 6b to the 4th minus 12b squared plus 24. So let's see if we can take what we've learned and factor this polynomial. Here we have x to the 6th plus 5x to the 5th minus 4x to the 4th minus 20x to the 3rd is all equal to 0. Well, for now, let's forget about the 0. We'll come back to that. And let's look and see if we can find any common factor first, because that's usually the easiest thing to do. We have a 1, a 5, a 4, and a 20. So none of these have a common factor. But we can take out this x cubed from each one because this is our lowest ordered power. So if we factor out an x cubed, we'll be left with x cubed on the outside and then x to the third plus 5x squared minus 4x minus 20. Now we need to further factor what's in this parentheses. So first I'm going to try grouping. I'm going to group these two together. So if we have x cubed plus 5x squared, I can factor out an x squared. So we'd have x squared times x plus 5. Now hopefully we can get an x plus 5 out of the other side of this equation. So we have a minus 4x minus 20. I can factor out a negative 4. If I do that, I get negative 4 times x plus 5, which is what we were looking for. So now we have x squared times x plus 5 minus 4 times x plus 5. If we factor out our x plus 5, we'll be left with x squared minus 4. And then don't forget we still have this x cubed out here in front. Now x squared minus 4 is a quadratic. So x squared minus 4 can be factored into x minus 2 times x plus 2. So then our factored equation is x cubed times x plus 5 times x minus 2 times x plus 2. And all this is equal to 0. So now to solve this, we need to find our zeros. Remember, if we multiply anything by 0, it's equal to 0. So the idea is to find a number that'll make each one of these terms equal to 0. Because if one of these terms equals 0, then it doesn't matter what the rest of them equal. It's going to equal 0. Well, the only thing that we can do to find x cubed and make that 0 is just to make x equal to 0. If we have x plus 5, and we want to make that equal 0, we subtract 5 from both sides and we get x is equal to negative 5. So negative 5 is a solution. If we have x minus 2, and we set that equal to 0, we would add 2 to both sides and we get x is equal to 2. So that's a solution. And then we have x plus 2. Well, if x minus 2 is 2, then x plus 2, our solution will be a negative 2. So to solve this polynomial equation, our solutions are x is equal to 0, negative 5, negative 2, and 2. And that completes our tutorial on solving polynomial equations.